Let's take a look at the process of solving a trigonometric equation that has a different period than usual. Sine of 3x equals negative 2/3 is a little bit more complicated than just sine of x equals negative 2/3, because 3x means that the sine function is going to go through a cycle 3 times as fast. And so we can start by thinking about what this looks like graphically. So just looking at the left-hand side for a moment, sine of 3x on a window that goes from 0 to 360 and has y values from negative 4 to 4 looks like this. Rather than going through a single sine function in that amount of time, it goes through the sine cycle 3 times because of the 3x there. So we can see right away that there should be 6 solutions. Negative 2/3 is a valid sine ratio, and if I add that line to the graph, if I add a line at negative 2/3, the solutions are going to be where these two graphs cross, and that's going to happen 6 times. Because the sine function, because the sine function is going through its cycle 3 times as fast. And so in the normal period of 0 to 360, we're going to get 6 solutions instead of the normal number of 2. So let's think about how to get those solutions. We're looking for values of x that fall between 0 and 360. So 0 is going to be less than or equal to x, and 360 will say 360 is greater than x. That means that 3x, the value of 3 times the solution amount, can fall between 0 and 3 times 360, which is 1080. So we can first start by trying to find solutions for just 3x and then convert them into solutions for x. So let's do that. We can use inverse sine to find a value here. Inverse sine of negative 2/3 gives me an angle measure of negative 41.8. But now that's a value for 3x. So 3x could equal negative 41.8. Of course, that's outside of our range entirely, but it's a good place to start. This angle happens to be in quadrant 4 because we're working with a negative sine ratio. So we get a value down here in quadrant 4. We can translate that into an alternative solution in quadrant 3 by subtracting from 180. So a second solution for 3x would be 180 degrees minus negative 41.8. So with the calculator here, I can take 180 and then subtract our earlier answer, and we see 221.8. Well, because we're subtracting a negative amount, that actually gives me a value that's in the range that I'm interested in. But let me mention, the range that I'm interested in is actually this range, because we're looking at solutions for 3x. So one possible value for 3x is 221.8. Because we're dealing with 3x, and I'm ultimately going to translate that into solutions for x, the upper bound is actually 180 degrees and not just 360. So other possible solutions for 3x come from adding 360 to this amount, just like we usually add 360 to get other possible values, and those are going to place us in a coterminal position to this angle in quadrant 3. So let me take that and add 360. I get another solution, 581. If I add 360 again, I get a third possible solution, 941. And if I add 360 one more time, well, now the angle's too big. But I've found 2 other solutions. So we have solutions, possible values for 3x of 221.8. 3x could also be 581.8, or 3x could be 941.8. Dividing by 3 will give us solutions in the range that ultimately we'd like our answers to be in. But for now, let me just leave those alone and turn to the other possible solutions. So we can also get solutions that relate to this angle in quadrant 4. And so let me start with that angle, negative 41.8. If I add 360 to that, I get a positive value. So another possibility for 3x is 318. If I add 360 again, 678 is another possibility for 3x. And one more time, we end up with 1038. Of course, adding 360 a third time would take us outside of the range we can go up to, which is up to 1080 for 3x. So three more possible values for 3x. 3x could be 318.2. 3x could be 678.2. And 3x could be 1038.2. To find the actual final answers, the values for x, I can take each of these values and divide by 3. So we can turn back to the graph here and confirm those are solutions. If we hit the trace key for a moment, we can double check. For example, 73.9 corresponds to that first place where the sine curve crosses the line negative 2/3. Y equals negative 2/3. 226.1 corresponds to that fourth solution. I hope you enjoyed the video. Thanks for watching.